You guys are so quiet. You could even have left your microphone to do the the what some noise there so that I know I have some people talking there. No, you're so quiet. So I have this data set here, and I had shared earlier in the group where I have. Let me try to. So in this data set, we have the tumor size because we realize that like testing the tumor size only won't be like a good like a predictor variable because assuming that you are going in boxing, like you are going to do some boxing, those game that involves like you know hitting one another and then you find that someone has hit you and then you get something which is like you have some can I call it a tumor, like you have you know some, what do we call it, like you get some something like a tumor. You can't say that that is cancerous because you are hit by someone. So that alone can be like you cannot be used as a predictor variable for testing if something is cancerous or not. There are some other things that can also cause. And then also in this one I included, like I got a data set where we have a lot of feature variables that can be used to like check if someone is cancerous or not. And then here, for example, on the edge, this tumor size is a continuous. It's a continuous. So basically, this one is a continuous variable on the tumor size, and then this one also is a continuous variable, and then this one is a binary where 0 represent those who don't smoke, and then a 1 represent those who do smoke. And then in the family history also we have, it's a binary variable where 0 represent like people who have ever had cancer, like for example in your family lineage, if you have some people who had like some cancer, it is 1. If not, it is 0. Then at the blood pressure also it is though I'm not good, like I'm not in the field of medical to test to like know if these are the contributing factors for cancer or not, but I just got some data set to use. So we have here blood pressure, we have these are cholesterol. So these are the things that you're going to test to see if you have cancer or not. So like for example, this tumor size of 5, the other time we were to like check if the tumor size is 5, we were saying that is it is cancerous. But now here we have the tumor size of 5, then at the age is 40, then the guy doesn't smoke, and then the family status, there's no what there was no person who had like the cancer. And then at the blood pressure, I don't know if this one is normal or what. I'm not in the medical field. Then a cholesterol, I don't know what it means. And then when you like try to check on these aspects, then you can tell if it's cancerous or not. And then at this one you can see the tumor size is 7, then the age is 43, doesn't smoke. Then in the family lineage, there's there was a person who had the cancer, and then at this blood pressure, I don't know if this one is abnormal or in the normal range. Let me try to do it. Let me try to check here. Uh, Normal blood pressure range. Normal blood pressure range. Hey, how do I read this thing? Normal blood pressure range. It is what does this value represent, guys? Those who have a clue on this stuff, you can help me understand this data. Anybody? Are we together? Or are you guys all of you are in software things. You're not into biology also. You're not into
Normal
medical.
blood, normal blood pressure is usually 120/80.
120 over 80.
Yeah,
So anything above 120 it is high blood
it's
pressure.
likely. Yes, exactly.
Oh, and then something that is below, and then it is low blood pressure.
Yeah.
Yeah, thank you so much. And then now for cholesterol, does this mean? Do you know? Do you have a clue about this stuff?
Let me just check.
Okay.
So, less than 200 milligrams per DL is normal.
Mm-hmm.
And then anything between 200 to 239, that's borderline high.
Okay.
Anything that is above 240 is very high.
Oh yeah, yeah, and I think this makes sense because on the blood pressure it should be 120, and then it's 148,
Mm-hmm.
and then the cholesterol also it is high.
High.
So I
Yeah.
think these factors like can tell that this guy has the cancer,
Mm.
the cancer, and then the cancer as like this one is in the binary option. If like they have a cancer, it's one. If they don't have the cancer, it is zero. So this is just for testing, guys. We don't mean like it has any, you know, a value. This is just like for demonstration purposes. They're not like the real. In fact, also I don't understand what this stuff mean. But I just wanted to have something big so that we can try to analyze it and use it to test our model. I did some cleaning earlier so that I can spend a few time on to show you how to train our models and those stuff. They are about 1,000, they are above 20,000 data sets. like the data that we have here. So the first thing we need to import, I need to add in this file in the same directory so that I can use the relative path to access the file. So let me go there, and then it is logistic regression, I guess. So I have that data set there. It's a CSV file. And then this one, let me give it a title like logistic regression. Logistic regression. So the first thing that we want to do is to import this file. And at this time we are using pandas. Pandas is a very powerful tool uh, for data manipulation. So I'm going to import, sorry. I don't know if you can see, and maybe the light is too much. It is the white. I'm using the light dim. Import pandas is an alias. So perhaps if the name is too long, if you don't want to fit in, uh, like to fit in the whole long name, like in this one, you can create a variable for it. Let me just try to create a variable for it. So I can call it, for example, something like path or a file path. I don't know if there's a keyword, built-in keyword in Python called path, but let me assign it to this CSV file so that I can just pass here the let me say data, and then I'll assign it to the to this method in pandas, or a function in pandas that reads such files, the CSV files. So it is pd pandas, and then at the function to read the file, it is like at the CSV file, it is read CSV. For a JSON, you'll use a JSON file, like a JSON file. Then I here just pass your path. Or let me call it file path. File path. File path. So basically, up to this point, this file will do what, will read like this code will do what, will read like this file in this notebook. So let's try to display some few things, because we have around 20,000 records. It might be hard if you try to to display everything. So we can only display some, for example, the head, like some few rows. Head by default, it will return like records, five records whenever you use head. But if you specify, for example, 10, 20, then it's going to read based on what you've inserted there. Let's see if we'll be able to read some the that file here. Yeah, it's so we have it here, and then okay. So we have this tumor size, like we have this data set, we have imported it our in our notebook now, and then now we have the tumor size, age, smoking. The tumor size is a continuous data, age is a continuous data, and then a smoking is a binary data, and then a family history is. And I remember, for example, if you want to use a data set from a hospital, they don't understand the language of machine. For example, they say that for example, smoking, they'll say, for example, something like yes or a no or a such value. So they won't be using these values. So you could use, for example, you can use a function for example, you can use a function for example, if a condition, or maybe if the response here is, for example, no, then you can replace it with there are several ways on how you can replace this one to be because machine now understand values, not those non-integer, non numbers, I think, or maybe string. Let me just put it as strings. And then this one is a family history. And by the way, if the classification was more than one, you could use the one hot encoding in pandas. I think there's a function in pandas also to do the same, so that in case you don't have to do all those things. I think I'll show you perhaps later, though it is in multi-class classification. I can show you maybe if we'll do it earlier. And then this blood pressure also is a continuous, we discussed earlier. Cholesterol also is a continuous data. Then this is a binary variable. Now we have this data in our system now, and we are good to go. So we need to define to give our feature variables. We need to create a feature variable because that you see. Let me see if I can be able to see that thing. That graph, it was for x and y axis, so that in the y, in the y-axis, that's the side of the prediction where one will represent. Let me see if I can be able to open that file. Where this part we have it's a binary choice, we have 0 and 1, where so this part is where we add in the feature value, and then on this other side, this is the probability. And the logistic regression function, it has the function itself, it gives you the logarithms of the odd. For example, if the odds, these are the what they are called, what, probability. So it converts it. For example, if it's more than 5, then it's going to give it 1. So the output will be 1. Then if it's less than 5, then it's going to return 0. So that logistic regression function, it has like the function itself, like the logit function itself, it has like some calculation or maybe some function or maybe some equation or maybe what can I put it, like it has some configuration such that whenever like values is like in your probability, like if it is above 5, then it's going to go to the side of the yes, the agreement or maybe the positive, and then if it is low, it will go to the negative. And the negative in this context, like for example, if it is in the cancer testing, it means that you are good. So yeah, so basically now we need to create like to give some feature like values to our feature to give like the values to our independent variable. So let me say for example x, I'm going to assign it to now this data, the variable that I've created here, data dot, let me drop, I'm using the drop method, and then here like because I just want to I want to use this I want to use this I want to use this part. I want to use this one. So let me just paste there. So this is going to be the feature variable is going to be in the what? In the x-axis, this side. It's going to be this side. But now, so to define it that way, we need to add in like another parameter there called axis. Axis, is it axis? We need to assign it to 1 so that it can be like for example, if you are in I think we discussed this stuff in the in what in NumPy. So for example, if you have one, then like for example, if you have some values, let's say you have a two-dimensional array with maybe 2 rows and then maybe 2 columns. So this is the first axis, and then this is the second axis. So this side it will now be the side of the rows. When you give it access 1, you are specifying this first part, access 1. So now because this one you've defined like the feature variable, so the other one you don't have. This one will just say we'll just use now the we'll use what the y. And by the way, you can use, for example, you want to check, for example, which functions, like maybe deducting about a function, like to learn more about a function, you can just click on Shift and then a tab. It can give you like some brief description about the function that it is used there, so that you can learn a lot. But it's a good practice to understand like each functions you are using. You just use it, Shift and then a tab, then it's going to tell you, like for example, this one removes rows or columns by specifying the labels, the label names corresponding to axis, and then all those a bunch of information there. Now for the x, I'm going to now y because this is like the response variable. This y-axis I don't like have to specify because it will automatically be the other side. So this one I'm going to give it just direct without specifying the axis or whatever it is. So basically I have now let me try to run first of all to be in the memory. So I have these values now, and we can do what we can now split our data into, because we have now today we have a lot of data. We have more than 20,000. It is 20,000. So we can basically split our data into like some 80% to be in the training, but there is a good practice to train your model with a lot of data, and then for testing can be even 20%. Now when we say something like a 20%, when you convert it 20%, it will be like a 20 is 20 over 100, and that should be 0.2. So you convert it to be in the without that percentage. So I'm going to split like 80% of our data into the training, and then at 20% we shall use it for testing. So there's a module that has like there's a package that has those function for working with for splitting our data set into the training and testing. So it will select randomly the data set into it will select randomly your records, like some will go to the training, then the other ones will go to the testing. So I think let me import it here at the top so that I may use it. So from sklearn, mhm, sklearn. By the way, in case I write something that is not quite good, you can just inform me because I'm not good with spellings. Model selection. By the way, you can always okay. Model selection. I'm going to import import train underscore test train underscore test underscore split. So this function, let me try to run first of all. So this function is going to like split our data, like some to the training and then others to the testing, depending on what value you gave for the training and others for the testing.
You understand, it should be split, not split.
Yeah, that's why. Yeah, thank you so much. I usually have issues with the spelling, or maybe sometimes when I talk and try to write something, I usually confuse things. Thank you so much for being observant, and that's really appreciate so much. So I've imported now our data set, and we can, for example, if you want to check what it does, you can just hit shift and then a tab, then you can see the function that it does. So these are the arguments that you should use, and then there's a doctrine on the same. Now, let's now split our data set into the train and the test. Should I be writing the comments, or maybe there's no need? Let me say x underscore train, x underscore test, x underscore train, and then x underscore test, and then the other one will be for y. Remember now these are the one that has x. These are for the feature, and then these are the ones. These are the they are the side in the side of prediction. This is for example y, y train, and then the y underscore test, the one that has small. This one they are in the this one are in the the in the side of the prediction, but in the side of it will fall under the that part of the data set for testing. Am I confused? I'm trying to illustrate something here, but it's not making sense. So let me now import this thing. Not importing, I've already imported. Now to use it. So this is our so this is we want to now split our data into this function. If you pass your arguments here, it's going to split your data into the train and the test. So the argument that we are going to pass here is what we had here at the top. So x as our feature, y, and then we need to specify the test size. These are the arguments there that you should pass. So the test size you should specify. By default it is none. So I should give it test underscore size. We said 20% will be 0.2, but now because it's going to generate those data randomly, for example, this is our data set. It's going to select, for example, this one, it can it's going to select things randomly, but we want, for example, our stuff to be reproduced, like in the event you want to reuse it, or maybe something like that. You need now to use something called a random state, so that you can reuse your train test, like the values that you've used in the training and then at the testing, like you can reproduce in that case. So you can use the random state parameter, random underscore state. You can give it any value, but in most cases they usually use 42. So with this line, we've done what? When we run this one, we will have splitted our data into testing, like 80% to the train, and then 20% to the testing, and then we've saved like that the value, like the records that have been used, like the data that has been used in the training and at the testing have been saved whenever you use the random state, so that you can save it, so that you can reproduce in future. For example, if you want to check prediction, for example, in future, you can reproduce the same thing whenever you use the random state. So now we need to import now the logistic regression. We need to import the logistic regression as well here at the top. Let me just add it here. Mm-hmm. From what? sklearn. By the anyone who has learned sklearn, or maybe how many are just using it and they haven't even learned what sklearn is, and the method and the classes there. Linear model. Hey guys, you can't even respond. Is it unnecessary question? Like, is it yeah, import logistic regression. Logistic regression, yeah, is wonderful. So let me save it, and then now we can instantiate this logistic regression class. But there is a class, and it has like some default parameters. It has some default parameters. When you hit shift tabs, it has like some default parameters. You can see, for example, something like this max iter, by default it is 100. But in the event, for example, in our case, we have large data set, then we need to adjust the hyperparameters here and other some other values. So we can't use it like, for example, if you just specify the other time we are using it directly, like without adding any other parameter there, like giving it our own parameters. It was using just the default values yesterday when we were using it yesterday. So let's instantiate that object. Like let's create an instance of that class. So I can call it, for example, something like a model. And I think I can just do what? Let me just use should I use the default values, or maybe I can I think it's a good practice, because our data set is too much. We need to increase the max iter to ensure that we have good convergence, because the reason we should, in the event like you have large data sets like the one that we have here, we need to like improve, like to increase that hyperparameter, or maybe that max iter parameter from that class, so that we may increase like the number of iteration. We may like increase the number of iterations, so that our algorithm will get like the best, or maybe the optimal coefficients in our like, so that we may use something which is correct, because sometimes we can give it small, and then you find out that it needs more, and then you've limited it, then it might throw some one in there. So I think it's a good practice just to increase. Let me just do it. The model I'm going to give it. I'm going to, because if you just use it this way, it's going to do what it's going to use the default values here. But now because we have large data, and then I think I can do what I can try mhm, to add in my values because I have large data sets. Or what do you guys think? Mnanyamazanga tu hivyo. Ah, niliwachanga last time ulikuwa active. You were very active the other time. I don't know what is happening nowadays. Am I logged out of the meeting? People are still there. Well, uh or maybe things are tough, but I hope it's not tough. It's not tough. So now we've included, like we have modified, or like we have instantiated our this class from the uh, scalan, so that we may override, like we understood, like while we were discussing function. I think I'm the one who taught, like for example, if you don't want, like for example, in your function call, if you don't want to, like specify a value to a function, you can specify the default values there at the top, so that in the event you forget, it will use the default values. So like we saw earlier, like for example, in this logistic regression function, whenever you don't specify, for example, it will use the default values, like you can see here. For example, the intercept scaling, it is 1, class weight is none. So if you do not specify, then it's going to use these default values. So, but because our data set is quite big, we need to increase this max iter here. So I've given it to 1000, and then with this one now we can test the we can test now we can train the model. Sorry, we can train the model. And how do you train the model? Any other person who wants to try to give me how I can train now this model? Any other person who can give me the code to train the model? Because I think this stuff you also did in the linear regression, if you were taught, or maybe I think that there was a that topic, even if I wasn't present, but I believe you discussed it, because we're using the same pack, like a module on the, like on training the model. We are using the same sklearn to train the model. Any other person who wants to try, or you just want me to suffer till the end? Hmm? Just want me to suffer till the end? Or you are at the rooftop of the? I heard there's floods everywhere here in Nairobi. Maybe I don't know where you are, but maybe the environment is not good for speaking, like talking. Hmm. Now let me show you that. Any other person? I heard someone.
Yeah, you can say model.fit x train y train.
Wonderful. Now, because we had splitted our data set into the train and test, so we can now pass here for like the values, like for training, like the ones for training the models. We can use like only some values for training the model. For example, we use this x underscore train. This one represent the large portion, that 80% for training, and then it needs to have like this side and the one at the top. So here I'll use now y underscore train, y underscore train. I think my spellings are okay up to that point. Up to that point, are we together?
Good. Can you hear me?
Hello. There's rain also on my end. I don't know if it is affecting you guys on your end. Still, are we together still?
Yeah, I can correctly hear you. Mama.
Okay, wonderful. Wonderful. So, um, so now I've done what I've trained now the model, that 80%, the large portion there to the training. So now we can try, for example, to predict. We can now try to do it. We can now try to test to evaluate like the performance of this model with the test values because we had splitted our values. You can see now we have the x test. We had splitted it. So here I can do what I can say, for example, um, I can say, for example, y underscore grade. I'm going to assign it to this model. Remember now this model, we have updated it with the the training data. We said that a Python is dynamic. Like for example, if you've created a variable and then you have assigned a value to a variable and then you reassign values to a variable, it's going to use the updated one. So whenever you use this model, it is using this one which is a trained. So I'll say model dot predict is it correct, and then I can pass in now the testing. I can pass here the x underscore test. So I think up to this point we are good. Let me put it in the memory, and then now we can now do some evaluations here. We can use the confusion matrix to test the accuracy and other things about our model, if it's accurate or not. So we can import the matrix from the same module. You can see how powerful this module is in Python, this sklearn. It is used in most cases in the machine learning. So I'm going to import a matrix in the same package, matrix. I think the spelling is correct. We can import the confusion matrix. Confusion. We can import now the confusion matrix. So the confusion matrix, I think I had illustrated it yesterday. Anybody who can try to maybe explain to the people what the confusion matrix does? We had discussed it yesterday. Any person who wants to try this one to explain what the confusion matrix do? Any good person? Are you able to hear me still?
Yes, we can.
Okay.
Mama.
Mm. You can try. Guys, you can cooperate just for this day. I won't teach again. It's just today. Okay, so now these are confusion matrix. This is like it has the matrix to like that can help us understand for example, the accuracy of the model and the precision, the recall, the F1 score of our model, so that we can see how best our model is, like in predicting the unseen like data, like whenever you use data which is not like trained, like we've splitted our model into the train and test. So we've passed, like in the training, we've passed only the 80%, then at the 20% it is in the test. So the 80% is already trained. Now we want to pass, so we've passed here some new data which is not in the train. So we want to test how accurate our model is in predicting the unseen data. So these are confusion matrix. It has the matrix like to test the accuracy of our model. By the way, I think I have something here. I downloaded something about the confusion matrix. I hope it's here. Mhm. So this is a symbol I just downloaded from the internet. Let me try to zoom in. I don't know if I'm able to zoom in. Mhm. Wow, too much. So this is a confusion. Hey, and it continues. Guys, you able to see this thing?
Yes, you're able to see it.
Yeah, so this is the confusion matrix. It looks something similar to this, where, for example, here we have the first row, it's for positives, then the other one is for negatives, then for positive, the other side, and then the negatives. So, for example, if you are testing like the model, and then you see that if you are testing the positive, like for example, if you are testing, for example, our one represent what? One represent in our case, one represent the presence of cancer. So let's say you are testing if the model accuracy, for example, if you are testing if the presence of cancer, and then you got the result on like the accurate result, the model produced the accurate results about the cancer situation. So you are testing that one, assuming that it's one. So it's going to be the true positive. You are testing on the positive, and then it brought the positive result, what you are expecting, like from. Oh, this is the actual. I think they have interchanged. Let me try to flip it so that it can be. Oh, why it is. So I think now our actual data is here. I think now I should read it the other way around. So this is our actual data. Let's say we are trying to check, like we are trying to predict. This is the predicted, like this side is for prediction. This is the actual value. We are trying to like to check if it is truly a positive. Like for example, if it's cancerous or not. Then the values you get, if they are accurate, it will fall under the positive, the true positive. But for example, if you are testing on the with these actual values, like on the positive, if you are testing like if there's a cancer, if you are just specifically testing for the presence of cancer, but it brought what you are testing on the cancer, but it brought what it brought those zeros. It brought those zero, so it will be under the false negative. Am I explaining correctly? Really? I think they have interchanged this thing, and I think it's kind of confusing me. I don't know if I'm explaining very well. Any other person wants to try? So this is our actual data. You are training on the positive, like the presence of cancer, but now it is now in this other category, yeah, negative. So the results it is in the negative. So you are testing on the positive, but the outcome became the result was zero. So it means that it is now under the false negative. Like this category should be in the positive side, but now it is in the negative. This part is for the negative, so it is in the negative. So that is false negative. Now this other side, you are testing on the negatives, like for example, the absence of cancer in your what, in your blood, or maybe in your skin, or wherever it is. You are testing on the presence of cancer. So let's say you are testing on the presence of cancer, but the result here was one, which means that ah I might like in this negative, I'm testing the absence of cancer, and then the result was one, which means that it has returned something which you are not like expecting. So it is the false positive, which is it is positive, but it shouldn't be here because you are checking on the negative. And then for this other side, you can see it's negative versus negative. So you are testing on the negative, and then it brought the negative. So these are the true negative. You are indeed like you are specific testing on the negatives, and then the result was negative. So it is called the true negative. So those metrics, for example, how to calculate like something like the accuracy, you will take these true positive, then a plus true negative, and then a plus over the summation of both these stuff, true positive, true what. Uh-huh. I'll revert to it later. It's getting complicated the other side. So,
Nehemiah,
yes, yes.
maybe I should just try and explain also
Yes,
and
yes, I'll
see if,
appreciate. Thank you so much for chipping in. I was wondering what
okay.
is happening. You're right.
So,
Mm,
yeah. So basically, we look at this. Neymar has explained perfectly that this is what we use it to measure the accuracy of our model. So on the first column, we have under actual values, we have the positive and the negative. You remember that we have isolated 20% as the test to test our test 20% of the data set to test the whether our model is doing well. So our model is going that 20% will feed it into our model, and what our model will bring out will be the predicted values. Now on the first column, we have the positive of the actual that this is what we are reading from our model. We already know the results, which is positive on this first column. The second column is negative. So, but what did our model now predict? We now go to the first row. So, first column positive for the actual value. Second column positive. I mean negative. So now row by row, what does our model predict? That's the predicted values. So on the first row, our model said this on this thing is the number of the true positive. I mean the number of the positives that our model predicted and is actually truly positive. That's why we have that first uh, uh, box of that first row. First row, first column, we have the number of truly predicted, I mean correctly predicted positives. On the second column, our model predicted positive, but it was wrong. It was supposed to be negative because actual says these ones are negative. So false positive now becomes the wrongly predicted positives of our model. That is, our model got it wrong. So how many did our model get wrong? That is what we get. Or maybe how many what percentage is what we have in that false positive. But on the true positive will be how many did our model correctly predicted as yes, he got it right. That's what we have in that first row, first column. Second row, first column, the actual value is positive, but our model say it is negative. So it got it wrong. False negative. True negative, it is truly negative that this our model got it correctly that yes, this was it predicted it as negative. Yeah, and it was actually negative. Actual value is negative. So the number that our model got correctly as true positive is in that first box. The number that our model predicted as truly negative it's in the lower right corner. So like the man is saying, you tally the number and put it in percentage form. That's what. So if we now have as true positive, maybe 60% or 70%, you will not be able to know that. I think negative, you will not be able to know okay, your model is doing well or not. I hope that helps a little more.
wow, that is wonderful. Asante sana. Is it Ray or Anthony? I really appreciate so much for chipping in. At least I had time to bring some water here, and people have understood very well. And that's the purpose of a discussion. Like if you leave it to someone, it's not good. It's good just to respond or maybe just say something so that at least someone will know that we are together. This one is not a lecture, by the way. I think you've said that it's a discussion. So now we've used now the 20% of our data. We are now doing what we are using it to test the accuracy of our model. So up to this point, we've just trained our model. So we want to use it to see how perfect our model is. So we are using the confusion. We want to use the confusion matrix to test the matrix. So for example, if we want to get the accuracy of our model, we will take this true positive, this the ones that were, for example, if you are testing on the true positive or you are testing on the positive, and then the output that you got in the positive, it will the true positive, the way Anthony or whoever has explained, plus the true negative. You are testing on the negative, and then you got the negative. You are going to sum these two plus over the summation of these other stuff like a true positive, false negative, plus a true negative. You are going to sum all of this stuff like this true plus. Let me try to do it. I don't know how I can explain it. Let me try to see where I can illustrate. Or maybe first of all, let me print out. Let me get some values so that I can be able to illustrate that part. So now we need like first of all we want to create the confusion matrix such as a similar thing like this one. We want to create something like this, and then later we shall go to individual aspect, like for example if it's precision, accuracy, and all that. So for confusion matrix, which variable can we use? And guys, sorry I'm being disturbing. I just want to see like we are together. The reason I'm asking is not like um I just want to see like I want us to be together. So anybody who can give me a variable that we can use here for our confusion matrix. Just a variable, any name. Confusion matrix. Okay, let me assume I don't like typing, and then I use something like a CF for confusion matrix, and then I'm going to assign it to uh, to what? To the confusion matrix. I think we have already imported. Let me just use it. By the way, if you want more documentation, I told you earlier, you just click on Shift tab, then you can see what arguments are passed there, and then there's always a doxing. That's why they usually say that it's important, for example, if you have a function, a method, a class, to have your doxing, so that someone who is new, like someone who is trying to interact with your code, will easily understand what function does. You can see now the importance of having the doctrine. A new person will easily understand it without even going to the documentation and learn more about it. So I have that confusion matrix. Let me use it here. And then now the values that I'm going to use here is going to be like we have now this y pred. I'm going to use the y test. Let me see. We have y test, and then so I'm going to pass here the y test, y underscore test, and then we are going to use also these are prediction, the predicted y pred, the predicted value. So let me say y underscore pred. Like we want to, okay, yeah, I think it's clear. So let me pass this one. We are using this predicted value against this test value so that we can get the accuracy of our model. Like we are using the original, like the trained via we want to compare between the trained what model versus the unseen, like the predicted, to see the accuracy of the model. So this one I'm just going to save it in the memory, and then perhaps let me also now because this CF will give us now the confusion matrix, which is four what is a 2 by 2 what this thing, sorry, it's going to be something like this one, but I want to have everything so that I can illustrate all of them at a go instead of printing out several. I'll come to it and explain in details later perhaps. So accuracy, I told you earlier, that is the summation of the true positive plus the summation of the true negatives over the summation of everything, including the true positive, false positive, true negative plus the false negative, all of them, and then you get the result. The result you get is now the accuracy. So we have a function that, like a Python, like this model, like this sklearn already has a function that is going to do that for us without us, doing the summation and all that. So whenever you use that function, then you pass your arguments there, then it's going to automatically calculate for us, and then I will get the accuracy. So it's called accuracy. Accuracy. Hey, my spelling is terrible. Accuracy score. Accuracy score. In this accuracy score, I'm going to pass the same data, the y test and the y. Let me pass everything there, and then let me do all for all. Then I shall print out everything. Then I will illustrate. There's a precision. I'm going to illustrate also what precision does. Precision. Spelling ya precision inaandikwaje? Precision. Is it this way? Precision.
Yes.
Yes.
Thank you.
Yes.
Yeah, let me use it here. We also have another one called recall. I'm going to explain also. Let me just print out recall. Recall. Here I'm going to use also recall. And then the F1 score. F1 score is going to be F1 score. Basically, I'm just trying to create variables for this one so that I can call it. Like once I try to call it, it will like print out everything as I go. So perhaps let me try to explain before we even print out. Now the accuracy, I told you, like the accuracy, if you are testing the model and you're checking on the accuracy, this accurate, as I told you earlier, and I'm repeating once again, this is like the proportion of the total prediction that were correct. Like you are testing on the true positive plus the true negative of everything there. So that is going to be the accuracy of your model. Now the precision. Precision, this is where you that's like the proportion of the positive identifier, the values that were identified in the positive side. For example, in the true positive, you are going to test on that one that were truly correct. So it's going to be these are true positive, then over true positive plus true negative. So the result you are going to get is the precision. So this model is going to calculate for us whenever you use the precision. And then now the recall, this recall function is going to give us the proportion of the actual positive that were done what? Like you see, these are precision. I don't know if I've explained this one very well. Like this precision is going to test. It's going to test it's going to test on these are true positive. It's going to test true positive against the true positive plus the true negative, like true positive over true positive plus true negative. If I'm correct, someone can correct me if I'm wrong. Then the result you get it will be the precision. Now the recall. This is all the positive that were identified, including this false positive, and then these are true positive against that were identified in your like anything that is positive which was identified in your like the output in the confusion matrix. And then F score, this is like the average between now the recall and precision. You are going to get the F score. Any input, guys? I think perhaps I might have confused someone. Anyone who can elaborate well on the same? You can see here I have an issue with the spelling again. Accuracy. Is this really the spelling of accuracy score?
Have you imported the accuracy score from sklearn?
Oh, baby, I haven't even imported all this stuff. I haven't imported any. So I'm going to here at the top from the same model like sklearn. Let me say from sklearn. Now this is in the mod. This should be in the what? This should be in the, or I should have used even the in the matrix still instead of using several imports. Or I can just, okay, there's no harm. Let me just use it here again. Matrix. But then you can give me now the code. Import each of those. Import. Anyone who can try to give me the
accuracy score
and the accuracy underscore score, like that.
Yeah.
Another one is
F1.
Yeah, F1 underscore score. Precision. I hope there's a spelling for precision.
No.
Singular.
Okay. Score, yeah. And then the other one that we haven't used here is
Recall.
The recall, yeah, recall. Underscore score. Let me give it, like, add it to the memory. And then so let's try to get at the bottom there. This one we had imported is a confusion matrix. Then at these other ones, let's see if we get the error. So if the error doesn't appear, then it means that we've used it correctly. So we can just print out everything. We can have this one, also this one, and then we shall try to check on the accuracy of our model and precision and recall and F1 and everything. Recall, then also the F1. Yeah, so you can see now on the what CF the confusion matrix, it's something like something similar to what is here. Something similar to what is here. So this is the side of the true positive. So you are testing on the true, like you are testing on the 1, and then this is the result you got. So we call it like the true positive. This the side that has 1, and then this other one at the bottom here you are testing on the false, and then it brought like the number of those zeros, like it brought this one, the number of 0 that you are testing, like as a negative, and then it brought. I'm using negative and positive to mean, like, for example, the presence of cancer. We know that it was represented by 1, so I'm calling it positive. And then at the absence it was 0, and it's going to represent the negative. I hope you are understanding. Maybe I'm using that positive negative the wrong way, but I hope you can understand. And then this other one, you are testing on the positive, but now you got these ones which are false, like they are in 0. You are testing on the positive, the ones. Then you also got this one. You got these values which are in the false, like this other side it is for the false value. So you got 64. Let's assume that you are testing if someone has a cancer, and then you got wait. This is the false positive, right? You are testing like the positive, then you got this one, like the values which are in the false. Anybody who can try to illustrate this, and it seems I'm confused here to illustrate. And it's fine.
Nehemiah?
Yes.
There's someone whose hand has been up for a while.
Yes?
There's someone whose hand has been up for a while, so
Oh,
I
I can't see
believe.
the other side. Perhaps they can just speak because I can't see the meat when I'm in this screen.
Edwina?
Oh, sorry. I think I've clicked on it by mistake. It's okay. Thank you. Continue.
Okay. So any other
Nehemiah,
person? Yes, yes,
there's a code I'm sending you in the chat.
yes,
Can you run it?
yes, yes.
Then we'll explain. Then we'll see. As in, I want to see something.
Yeah.
But you have to import first the confusion matrix display.
The confusion matrix, this one.
And you have to import it
Is it from which module?
from sklan.
SQL what? Just there.
Let me confirm. sklan.matrix still.
Still in the matrix. Let me add it here first.
Change your model here. We have written RF model. Put your model name.
The model, I think I used just model. Let me see. I just used model, yeah. I've run. I don't know. Oh, this is wonderful. This is wonderful, wonderful. I think we could have used this trick long ago. Yeah, too. So you can go ahead and illustrate by the way. You seem to have a good understanding. Yeah, for me, I was using positive, but I think you used the correct term, the labels, instead of positive and the what.
But you see, the Nini is the one which generates for you like that.
Yes?
The sklan, as in, the sklan will automatically label it for you.
Yes, yes.
So
Oh,
now,
mm, mm,
take me back to your other code
mm-hmm.
where you had the other confusion matrix.
Let me zoom. Here,
1916, 1948. I go back.
mm-hmm.
Oh, okay.
Let me zoom out.
Yeah. So now we can go ahead. I just wanted to confirm something.
Maybe you have some any input. By there, you are welcome to contribute. It's not like you have any input you want to add in, or I should just. Yeah, I think let me try. Or you have something maybe.
No,
Let me.
no, no, no. I was just giving you a labeled version of the confusion matrix.
Wonderful. So I think let me use the one
Mama,
that.
let me try
Yes,
and
yes,
explain. I hope
yes.
yeah, I've been having issues with network, but I can try and explain this confusion matrix.
Yes, yes.
So, in my understanding,
Mm,
it shows that it's made 64 on
mm,
this right side on the top.
mm,
So it
mm,
has made 64
mm,
false positive,
mm,
which means it is predicting cancer when it is not present
mm,
64 times.
mm,
Then this 72,
mm,
it is predicting 72 false negative,
mm-hmm,
so failing to predict cancer
mm,
when it is present.
mm,
And then these yellow ones
mm,
are the true positives and true
mm,
negatives.
mm-hmm.
Yeah, that's how I'm understanding this matrix.
Thank you so much, Lorraine. And I can see now the importance of accuracy in this binary classification. For example, you are testing on the presence of cancer, and then you've identified like 72 people don't have what cancer. Let's assume that you are just relying on the model, and you don't like want to try it like to test it like a doctor by themselves. They're just depending on the computer like the model. Then these people are going to die because they are going to live assuming that they are healthy. Kumbe they have what? They have cancer. So they live then they are going to die because there's cancer in, or maybe it will worsen. And then on the other side, for example, someone was going to, someone is healthy, but uh, uh, it is like he or she is identified to have cancer. So he's going to the medication, or she is going to the medication of cancer, or maybe cancer treatment, yet they don't have the cancer. And then you can see it's going to be very, very terrible. That's why the accuracy is most considered in the, in the logic regression, like accuracy, especially if you are doing something involving, like something which is very, very serious. For example, in the medical field, you need to be very accuracy. You can see though a model, it is 96% accurate. No, this is, the first one was accuracy. Yeah, this is accurate. Accuracy of our model, it is 96. Now this one is going to take like this true, these are these values over all these stuff. So it's going to get these values. Then the precision, as I told you earlier, how accurate your model is at predicting the correct values, the true values, the positive, or maybe let me say the positive value. So you're going to say, for example, this is positive. You're going to take these 1916 over 1916 plus this one. So you're going to get the what? The precision. Then now the recall. This one you're going to test on the on the on the positive. Like you're going to take both the what the those which were identified, both the ones that were identified in the how can I explain it? Mhm. The proportion of the actual positive that were correctly identified, I think. Have I explained that part well? Any other person who wants to try maybe to explain the recall? Any input? Abraham. Abraham, today you are very quiet. You say that it's raining. Also on my end, I think it's raining. Anyone who wants to add in an input about the recall? I think in the recall I haven't illustrated well the recall. So in other words, you are going to take the values, even if in the you are testing in the in the false negatives, then you find that you had the positive values there in the false. You are testing on the false, but you had those are the false negative. You are going to take those which ones, the ones that are positive. You're going to take those are positive ones, so that you can get now the recall. Though I haven't explained it very well, but I think there's this function we can use the doctrine to get the illustration. So let me just see. Mm-hmm. It's not even explaining very well. But any other person who can add in an input, for example, you can try to illustrate between the precision and because now the F1 score, this is the the average between the precision and recall. So once you understand well the recall and the precision, then the rest is going to be easy. Any input, guys? Any good person who wants to help others understand more?
Nehemiah,
Yes, yes,
I can say recall ideally
yes.
tells us what percentage
Mm,
of total actual positives
mm,
have been predicted. So
mm,
in this case,
mm,
uh, so when you go back to the chart down there,
mm-hmm, mm-hmm,
so the actual negatives are 72 and 1948. So
mm,
those are the actual positives. So
mm,
how much of that actual negative has been predicted correctly? So it will
mm.
be the true positive, which is 1948,
Mm-hmm.
divided by 72 plus 1948. So that's ideally recall.
Wonderful, wonderful. Any other person who wants to chip in? You're correct, but maybe someone else has something maybe to say. We don't want to leave our genius here in the call. You know, we don't want to do that. We need to give them an opportunity to address the is it the community, you know, the community of students, the learners. Any input, guys?
Maybe I just chip in just a little more.
Yes, yes.
But I believe you guys have already explained it very well. Um, I think another word for recall is sensitivity.
Mm-hmm.
So that it measures the ability of the model to capture
Mm,
all the positive instances in data set. How sensitive is the model
mm,
to capturing all the positive instances, and as I explained, the correctly predicted uh, over the all the positive instances.
mm,
So that was sensitive. So what I want to bring out. Let me just read a little of what ChatGPT says. Maybe it will help some.
mm-hmm.
So recall measures the ability of the model to capture all positive instances in the data set.
Mm,
It calculates the ratio of true positive predictions to the total actual positives,
mm,
you know, indicating the proportion of positive instances that were correctly classified.
mm,
So it gives it says it calculates in the instance of in the scenario where missing positive instances
mm,
is more crucial than having false positives.
mm,
For example, in spam email detection,
mm,
high recall ensures that most spam emails are
mm,
correctly identified, even if it means some legitimate emails are mistakenly classified as spam. However, high recall may lead to a higher number of false positives, which might not be desirable in certain applications. In summary, according to Kadir, says accuracy, precision, and recall provide different perspectives on model performance, and the choice of metric depends on the specific goal that we are trying to classify.
wonderful. Thank you so much. I think what I'll do, you guys are very, very genius. Like you're very wonderful. So I think what I'm going to do, let me write for you the equation so that you can know how you can explain it on your own or with your own words. So, for example, let me just write, for example, accuracy. You are still able to see the what the code the things here. Okay,
Yes, yes, yeah.
let me write the code so that you can know how to like define it with your word. So for accuracy, I told you earlier, like it's going to be the the true what positive. Here, let me make it a string so that, or maybe let me just make it a markdown so that you cannot.
Or just put as TP instead.
Oh yeah, yeah. By the that's very short, a good shortcut. So TP plus T and Sindo, and then over the total prediction. So total prediction, if I use TP, it will be similar to the, let me this one just write in
Okay.
quotes. Total prediction. And then the other one was what? Precision, right? Precision is going to be like this one is true, or let me say TP. TP over, it's going to be TP over TP over TP plus FP, right? For false positive, FP. So the result you get here is going to be precision. Now the other one was recall that you've just explained here. So this one is true positive TP. Let me write first of all recall. You say the other word was what? Sensitivity, right?
Yes.
Sensitivity. I have issues with the spelling. Sensitivity. So this one is going to be TP, true positive, over the TP, the true positive, plus the false negative, which means anything which is false negative, which means it is under the true positive, like it is in the positive. Anything which is not negative, it is positive. So you're going to take the summation of all the, like you're going to take the true positive over the summation of any positive thing. Anything, for example, that was identified as false negative, which means it is automatically in the positive. So which means that it was identified as false. Instead, like it should be in the negative. So you're going to take anything that is positive, put TP over the TP plus the false negative. So I think you guys, you can come up with a good definition on the same. Some of us are not good in English, but we had some powerful people here who have just explained it very well. And then the one the F score, I think that one is should be should be what? Should be easy, because this one is going to be is it really like the average between the precision and recall? Is it the correct definition? The
That's
average
correct.
is correct. But now to put it in equation, I don't know. Let me say f score, f score. I don't know how to. How can I put it in equation? But I just say at the average between the. Will it really make sense?
Thanks 2 times
Two times.
recall.
Sorry,
Yes.
two multiply by
2 times recall.
2 times recall. Should I? Let me just say recall
Times precision.
times precision. Should it be within the bracket so that these two multiplies? Oh, by the way, it's just the same. No, it's not the same.
Yes.
So
It's
it should,
actually still the same.
yeah.
It's still the same because it's multiplication. Yes, but times precision
No precision.
and then close brackets divide by recall.
Sorry. Divide by it. Recall plus recall. Recall
That's
plus precision.
yes.
Precision. So in other words, all this stuff is just, it means that the average between the precision and the recall, when you use it like in the layman terms, but now in the equation it is this way. Any question, guys? You see how the logistic regression is, or maybe machine learning, how easy it is. From the linear regression, the decision trees, up to this one, it's very, very easy. Just replacing things, then you get your results. Any input, guys? I told you that I could also explain how to do the one hot encoding. I don't know. Today I managed to do it like to finish within my time frame, like at the time I was given. Today I've tried, man. You should clap for me. You should clap for me. Yeah. So. So any from this, like from this model evaluation, what can you tell, or maybe what can you check? Like for example, what should be considered on like the model performance, like to increase the model performance? What should be considered based on what we've discussed up to this point? My question is It's not good. It's not like a designed properly. But I don't know anybody who has understood the question to try like for example in the aspect like in the event you are trying to do a binary classification with logistic regression. So what things should be considered basically for the accuracy of your model, like to improve the performance of the model? Because for me, I think the first thing should be like having balanced data, like assuming that you have, let me see, you have like for example you have only few in the negatives and then a true, like in the true there are very many. So I think the model can be biased because it is trained more on the ones which are positive, like but in the event for example the negatives are too much, and then your model can be biased because it is fed with a lot of negatives, so it is more like it's familiar with most negatives, like negatives. I mean I'm addicted to this term, but I mean the side of the zero, the side of the zero. So basically, like having a balanced, a balanced features, or maybe a balanced what? A balanced data in the trend, like both in the negative and a positive. Again, I'm repeating negative and positive. But I'm using that term because in the in the confusion matrix, they are also using this term positive and negative. So any other input, for example, guys, based on what we've just discussed today, what should be considered to improve the model performance? These are logistic regression. By the way, have you gained anything in this discussion?
Yes,
Hi.
I've gained something.
Okay.
Yes. So what can you say about our model? Is Linda around? Linda, is Linda around? Eve?
Nehemiah,
Yes, yes.
hi.
Hi.
Can you share this specific document after the meeting?
Yeah. I'm going to share it in the group. By the way, you see
Okay.
the other time when I was sharing my stuff, my nini,
Yeah.
some people reported my GitHub and it was suspended. But I'll share directly in the group. I'll share about the dataset. I think dataset I had already shared. So I'll share
Yeah,
this
you had
not
said that one.
directly. Yeah, I'll share
Okay,
it.
fine. Thank you.
Yeah. So guys, I want us to finish with this logistic regression so that you may be. There's something that I wanted to show you about one-hot encoding, but I think this should be in the multi-class classification. I think we can, if I'll be present, we shall talk about it, or maybe any other person can teach that. Is someone talking? So if there's no one who wants to talk or maybe ask a question, I think I should end it here. Let me stop the recording. Hey, I pity the